Alright guys, this is Unit 6, Lesson number 8. Today we're going to be talking about linear versus exponential functions. Very important unit to make sure we clearly understand how to do both types of functions and the difference between those. So linear and exponential functions share many characteristics. This is because they are based on two different but very similar sets of principles. So linear functions are based on repeatedly adding the same amount, like their slope. Constantly have the same rise over run, adding 2 each time, or going up 2 over 3, something like that. Exponential functions are based on repeatedly multiplication, because remember that's what an exponent is when we say 2 to the third power, it's 2 times 2 times 2. So we're repeatedly multiplying, that's why it's exponent, by some same base, and you guys know that. So exercise number 1. The two tables represent a linear function and an exponential function. Which is which? So we want you to tell us which one of these tables is linear and which one is exponential, and explain. Use these definitions to help you. So go ahead and try that now, and only hit pause and only hit play once you have an answer. Okay, how'd you do? Let's see what you said. Hopefully you got something like this. Alright, so this first one you should have recognized as exponential function because each of these are being multiplied by 2, so this is repeated multiplication over and over again. So that's kind of what we wanted to say in here. You don't have to say exactly the same, but as long as we said something about factor means multiply and so does product. So if you just recognize that these are being multiplied by the same number, that would be enough explanation. This one here is you're adding the same amount. So these are increasing by the same amount, like up 3, up 3, up 3. So that would be linear because we're adding. And again, you don't have exactly what we're saying as long as you understand that this is repeated addition, or you could say there's a constant rate of change that's going up the same amount each time. All right, so let's keep moving on here. So now what they want you to do is use the tables above. You should be able to find the equation in standard form for these. So I'll give you a little hint, it's been a while, but linear equations, remember, we're in the y equals mx plus b form, and we've been doing the exponential form, so you definitely should be able to do those. So give that a try now, see how you do. Alright, so for these ones, table 1, remember, was exponential, and you guys should know the form of the y equals the a and then b to the x, where a is your initial amount, which they gave us. If we go back to the table, we can see the initial amounts right there. And then we found out that we were being multiplied by 2 each time. So that's where the base came from. And then there came the equation there. Sorry, let me get off that. Then over here, remember y equals mx plus b. Y is this is the y-intercept or the b. And again, you could find that by looking here. You should know that that's the y-intercept because the x is 0. And then going up 2, that's pretty much a slope. So now you can find a slope by doing the difference right there. Okay, so you should know delta y, delta x. And again, we go back and forth, but you can see that these are the y's. They're increasing by 3. And these are increasing by 1. So there is your change in y over change in x. And you can come up with these equations. So you really do this very important that you could come up with this exponential equation and this linear equation by now looking at tables and points. You got to get good at both of those. All right, so let's keep going. So on this one, this is a little interesting fact. What we're going to do is try to come up with the equations and graphs for both of these. Now, it's been a little while, but if we gave you 2 points, you should be able to come up with an equation for that. We've done that on the previous units. Now, when we give you 2 points, could you come up with the exponential? So we want you to find the linear and exponential equations that would produce both of these. So put it in this form for one and this form for the other. And then go ahead and check your equations before we do the graphs. So try the equations and then we'll talk about the graphs in a minute. Do those now, please. Alright, so let's see if you came up with these equations here. Oh, I put the graphs on, but not a big deal. Alright, so when we're doing these, when you're trying to find the linear, remember we need to find the slope and intercept. you should recognize that that's the y-intercept right there. Since the x is 0, that is the y-intercept or your b. And then remember, you just have to find the delta y, delta x. They're change in y's over change in x's. So when you went from 12 to 3, that was negative 9. And when you went from 0 to 1, that was 1, obviously. So there's your slope. And then once you find the m and the b, you could just go ahead and plug them in and write your equation. So you should be able to come up with those given 2 points. Now this one we haven't done yet, but let's see how well you did. So you should again recognize that that was your starting amount. So that's your a. And then you had to find what things are being multiplied by. So what did they do to this y? What did they do to get to that one over there? It's one way you could look at it. To me, they divided by 4. Or you could find the change, what he did kind of here. 12 times something equals 3, and there you go. So that is what's being multiplied by, and that's the 1/4, so that's your change agent. And then there's your exponent there. And then to graph these, you guys should be, the linear one was easy. You could have just graphed the 2 points, drew a straight line. And then we could see that since this is 1/4, this is decreasing. And both equations had to go through these points since these points were part of both functions. So that's what you kind of based on your curve, is it had to go through that other point. So something like that. All right, let's keep going. Okay, so remember with linear functions, they have a constant rate of change, so they are increasing the same amount each time. That is not true for the exponential. So we're going to kind of look at the average rate of change for exponential functions here. So they gave us this exponential function. They gave us this table of input and output values. And what they want you to find is, could you come up with the rate of change for these different intervals? So from between 0 and 1, 1 to 2, 2 to 3, and 3 to 4. What is the rate of change just for those ones, not from all of them, okay? So just do those each. So try those now, and only hit play once you find the answers. All right, let's see how you did with these, and hopefully you came up with some stuff like this. So you can see basically, remember, rate of change is change in y, so obviously those changed by 4, and those changed by 1, so that's this first one here. And then they just kept doing the same thing. Those changed by 8, these changed by 16, and then those changed by 32. So you can see that the rate of change is increasing as we go, and it's increasing by the exact same amount each of these being multiplied by. So basically changing these by 2s, multiplying by 2. So that's different than a linear function that has a constant rate of change. All right, what is clearly happening to the average rate of change here as it gets larger? I guess I kind of already talked about it, so we could just write these in. It should come up here. Maybe there it is. So the average rate of change is getting larger as x gets larger. In an increasing exponential function, one where the base is greater than 1, this will always occur and make the function's graph curves up. So it's going to increase each more, so that's when we start getting that curve action here, not a straight line. Okay, hit pause if you need to write everything in. And here we go. So exercise 5, we're going to talk about slope. The fact that the slope of an increasing exponential function is always increasing has some weird consequences. So consider the linear function here and the exponential function here. Both of these have the same starting point, our y-intercepts, you can see. So we're going to use our calculator, and they want you to graph both of these and use this range here. Okay, so just do that first. So plug those both into your calculator. Here's your window range, and go ahead and sketch those onto your notes. All right, so on this one, hopefully you got something like this. Okay, so they both started at 5, and you could just see the linear one here. And you can see the exponential here. Now this one's growing kind of slow in the beginning, where the linear just skyrocketed because it's growing by 20 each time. So it looks like the linear one's growing much faster, but remember, we're only up to 3 on our x. So let's give this a try. Do the exact same functions, but change your window to 150 on the y and 6 on the x, and try graphing that. So change the window settings and now take a look at it. All right, so when you did that, maybe you got something like this now. And you could see that the exponential function is actually starting to grow really fast once we pass this point here. But this one's going to grow the same amount, where it's kind of slow. This one is now increasing by tons. So if this one was at 150 now, the next time, since it's doubling, is going to jump way up to 300 and be off the page, where this one's just slowly creeping now. So over time, exponential functions grow really fast. That's why we say things are growing exponentially. They're getting more and more each time. And let's see what we got down here. So, although the lines appear to rise more quickly than the exponential, we're talking about line to linear. At first, the exponential eventually catches up and surpasses the line. Why does an increasing exponential function always catch up with an increasing linear? I guess I kind of talked about that, so again, we'll just fill this in together. So the average rate of change of a linear function is constant, so it always rises at a constant rate. The average rate of change of an increasing exponential, though it's always getting larger, eventually its rate will get larger than the linears. So over time, give it some time, the exponential function will always catch up to the linear because the rate of change is like doubling or tripling and it's getting bigger each time. Alright guys, so hopefully you got all that in there, and we'll give some of that practice in class tomorrow.